All right, so I am Jonathan Helmus, and today I'm going to be talking about exploring open access weather radar with the Python ARM toolkit. So by open access radar, I just mean freely available to everyone where you can go and download it from the internet. I'm going to do that. All right, so just a little bit of background very quickly. Weather radar are instruments that send out microwave pulses. They can probe large regions of the atmosphere. Typically, we think of them as detecting precipitation, and with that ability, they can track and predict severe weather and tornadoes. But weather radar can also be used to study clouds and other atmospheric systems, as well as provide long-term climatological parameters if you have a long-term data set. So Scott Collis and I created the Python ARM toolkit a few years back, which is a package to work with radar data within Python. It provides a lot of the functionality that you'd need. So you can read in radar files in a number of formats. We have visualizations built on top of matplotlib that are pre-canned, but you can also customize. We can also correct a number of artifacts that you typically see in radar data using, hopefully, the standardized algorithms. And finally, a lot of our users want Cartesian grid, something that's not in range, elevation, azimuth, polar-like coordinates. And so we have the ability to interpolate onto a Cartesian grid. And finally, also, all of this data is put into a common class that a lot of our users actually extend and use to grab the data themselves to build more advanced analysis. All of this PyArt is open source. It's available on GitHub. It is a compiled package. If you want pre-compiled binaries, I have them on Binstar. You can install a version that's about 2 months old, and it will work fine. So just to give you a little flavor of how PyArt works, so this little script is going out to the National Weather Service, grabbing the last the last radar sweep from the San Antonio radar, and we plot it on a little grid. Unfortunately, it's not raining or anything fun like that, so we basically just see background noise. I was really hoping it would downpour today because it would make all these visualizations a lot better. So the first source of open access data is the Nexrad network, also sometimes called WSR-88D. So this is a network of about 160 S-band radars across the country. They're jointly operated by the National Weather Service, the FAA, and the Air Force. You get about a full volume every 5 to 10 minutes, and these can see quite far, about 460 kilometers in radius. One thing that is interesting, especially to weather geeks like me, is that in 2010, they started upgrading all these instruments to be polometric, so you now get some additional variables that can tell you more about the amount and type of precipitation that you're seeing. So Nexrad distributes its data in 2 different formats, level 3 and level 2. So level 3 files are very small, usually 5 to maybe 15 kilobytes in size. They contain a single reduced resolution sweep of a single radar moment. So these are really good for generating visualizations. They're small, but they just contain a little bit of data. The National Weather Service also provides their post-processed products, so things that have gone through their processing pipeline, such as accumulated rainfall and hydrometeor identification in this format. This format can contain a couple of different, it can do radial, it can also do raster images and a few other. PyArt only supports the radial images, but I believe MetPy supports everything. So if you're interested in those, look at that package. Level 3 data is available directly from the National Weather Service through an anonymous FTP site. This has near real-time data, which is what we grabbed in that first snippet, but it also contains data for about 24 hours. If you want historical data from going back all the way to the early 90s, you can go to the National Center for Environmental Information, and they have all the data. That used to be NCDC, which was a whole lot easier to say very quickly. And so to use that, you just put in the dates and the location of the instrument that you want. You put in an email address. In about 5 minutes, you'll get an email with a link to an FTP site and a website where you can download the data. So how do you use that data in PyArt? So this little cell, we just import PyArt. The syntax is really easy. This is a file that I downloaded, I think, off the NOAA's website. So you just use pyart.io.read. If we want to know a little about that information, we have an info method off that will kind of print out everything. This is kind of like NC-dump, except on a radar file. And if we want to plot that data, we have to make a display object, and then we can call the plot method off that object. So this data is from June 15th from the KLOT radar, which is right by Chicago. So on June 15th, we had a whole bunch of rain. We had local flooding. And so we get rather significant returns from KLOT. Now, if we want to put this in a little bit more context, we can actually display this on a map. So this is the N1P product from the National Weather Service, which is the 1 hour accumulated rainfall estimated from the radar returns. And for this, we're using a radar map display, which will also plot up a map. So this is Lake Michigan here. This is Michigan, Indiana, Illinois, and Wisconsin up here. And this region right around here where we see really significant over ½ an inch an hour rain, that's right by my house and Argonne National Lab. So we got quite a bit over that period. So Nexrad also comes in level 2 data. These are larger files, 5 to 25 megabytes in size, compressed. But they contain all the moments of full resolution and a complete sweep. So 9 to 20 basically scans around a region. So this provides a real three-dimensional view of the atmosphere. One thing to remember is these are base radar moments, so there's no correction or quality control applied. So you might see some artifacts in these. If you're a radar researcher, these are really fun because you can try and test out your algorithms, but sometimes you would rather have the National Weather Service fix your data for you. Level 2 data is not available directly from the Weather Service. You have to, they send it up over a satellite, and a couple universities and research organizations do make that data available on the internet. Have a couple of them listed here. Usually that's for a few hours, maybe a few days. But if you want historical data, you can get it again from the NCEI. Same procedure as level 3 data. So in PyArt, we can read level 2 data too. The syntax is the same. So this is the same sweep of from the radar near Chicago, but this is full resolution. So you can see some more finer details if you look carefully. The other thing is, if we look at the information on this, this has a number of different radar moments, and we can see we have 19 sweeps, and the number of gates, which is basically the range bins in the thing, is quite high, so 1832. So this is the full resolution. We can look at other sweeps, so this is basically the 9th tilt, so I think it's 3.2 degrees up in the air. So this is looking higher up in the atmosphere. We can also look at other moments. So this is the velocity. This is basically a measure of whatever that the radar is scattering off, how far is it, or how fast is it moving towards or away from the instrument. So another source of open access radar data is the terminal Doppler weather radars. So these are C-band instruments located near the major airports in the United States. They have higher range resolution than Nexrad, so they have smaller gate spacing, but they don't see as far afield. As you can see from the map, the coverage is much sparser than Nexrad, but there are a couple major metropolitans, so Washington, D.C. and Miami, where there's a number of instruments really close together, which can make for some interesting science because you can combine data from those instruments. Only level 3 data is available to the public from these instruments. It's in the same format as Nexrad level 3, and you can get it from the same National Weather Service website or NCEI. So I'm not going to run this because this takes a couple minutes to run, but this is basically, I downloaded the reflectivity data from the terminal Doppler weather radar at O'Hare Airport on that same June 15th day, And this just used Matplotlib's animation function to create a little animated GIF of the data from that, which then you can see the storms actually move towards and across the airport. It's fun to look at. Yeah. So the third source of open access radar data is the A in PyArt, which is the Atmospheric Radiation Measurement Climate Research Facility, or ARM, which also gets confused with the architecture. So this is a Department of Energy program. It runs a number of instruments and makes that data publicly or available to free to the public. And we operate a number of scanning weather radars. We have basically two types. We have precipitation radars and cloud radars. All the cloud radars have two antennas mounted on the same pedestal, so we scan out the same region of air at two different wavelengths, which we're hoping can provide some interesting science. ARM data is available from the ARM data archive. You have to register, just provide your email address, your name, and then you can order data through a web interface. The data is staged to an FTP site, which they send you a link to. ARM tries to provide as much data as it can in netCDF format. For the scanning weather radars, we're using the CF radial convention of how we organize our variables and metadata. If you don't like web interfaces, you can use this ARM archive module that I wrote, which provides the ability to search, order, and download data from the ARM archive through Python or a little command line interface tool. So really quickly, we'll read a little bit of data from ARM. So this is from our C-band instrument in the southern Great Plains. And this is during 2011, during a field campaign where we were looking for convection events, and you can see quite a bit of data. These are polometric radars, so we can see some other moments. So this is normalized coherent power, basically how the quality of the signal. We can also load in other data. So this is a scanning cloud radar from a Finland deployment in 2014. This is kind of a big file, so it takes a little bit of time to load. But this was set up in RHI mode, so it was scanning from horizon to horizon by changing the elevation angle as opposed to scanning around. But it's basically seeing this separated cloud, these two cloud layers. And one final little thing, so we have 3 X-band radars in southern Great Plains that are all located pretty close to each other. And so the southeastern radar was seeing just the edge of this storm, but if we look at the southwestern, so this one was basically right on top of the storm. And so the question is, can we combine those data to see a larger field of vision and maybe correct some of these, this missing data and these artifacts. And so PyArt has a little bit of ability to take multiple data from multiple instruments, combine it to a single Cartesian grid, and so you can get some smoother data, and you can replace if you have bad data in a couple places. And so with that, I just want to acknowledge some of the other contributors to PyArt, point out some other interesting programs that have built on top of PyArt and also our Open Radar. So ArtView is an interactive GUI that Nick Guy wrote that is on top of PyArt that provides, if you want to just point and click and go through your data that way. And then Tim Lang has built some nice algorithms that basically uses PyArt for I/O and some very simple corrections. And so I'll leave you, this is about a 24-hour scene from the San Antonio network, or the San Antonio Nexrad. It was supposed to be up to date, but my script never finished, so it's, I think, from this morning. But with that, I'd be happy to answer any questions that you might have, and thank you for listening. Yeah. So we're using objective analysis Barnes interpolation. And you can either choose Barnes weighting or Cressman, or you can actually provide your own.
I would point out, where you spot it, you have to look at that image, you can see the backstay there. So you have to look just above where the star is there, and wait, and... So you know, it's the backstay.
So we can only plot 2D data, but if you take a full like level 3 or level 2 data, it does give you multiple tilts, and you can look at that if you could figure out how to visualize it. Yeah.
Let's just go to a web app like AccuWeather. What do I get?
So I think that's usually level 3 data, but I don't know. So there's like 100 and some products in level 2, or I mean in level 3, and so that you can either have like the average of the reflectivity or the maximum, and if I know if you go to the National Weather Service, they have a couple and they'll actually let you choose, but it's usually level 3 data.
AccuWeather, it's so hopeless to make it look pretty.
Yeah.